Today we're looking at section 3.2. This is truth tables and equivalent statements. We're going to take a couple of things that we talked about last time, conjunctions and disjunctions, and explore them a little bit more deeply. And we're going to do that as it relates to a concept called truth tables. Truth tables are a logical way of organizing information, kind of like Venn diagrams were as well. They're different, but they're that same idea. We're trying to find a way to organize our information to figure things out. What we're working with today does not have a whole lot of direct, what good is this going to do? Like, how's this going to really work? Bear with me, we'll get there. There's a little bit at the end that does, but most of that's going to come in future lessons, okay? So today we're just going to establish how truth tables work and what we can use them to do symbolically. So to start with, conjunctions. We talked about this one last time. Conjunctions are and statements. And they are written with an upside down V between them. And statements are true when both statements are true. So we're going to create a truth table, but it will help us to create the truth table if we have a little bit of context to think about as we work through it. So I'm going to create a couple of statements that are just kind of some dummy statements so that we can talk together about these ideas. So my P statement is going to be, I am a woman. And my Q statement is going to be, I teach math. And I'll show you how we're going to use those. Okay, so we're going to create a truth table. So a truth table looks like a list. And so we're going to create a horizontal bar and a couple of vertical bars for what we need on this one. The first two pieces in a truth table, and sometimes the first three if we have three statements, are simply the symbols that we're using to represent our statements. In this case, P and Q. Okay, so we're going to have a column for P, we're going to have a column for Q. And then with this particular one, we're looking at what happens when we combine them with an and statement. So my third column header this time is going to be P and Q. And what I'm going to do next is I'm going to talk through the way we set up a truth table sort of conceptually. And then we're going to actually look at it and say, okay, but looking at it sort of from a detailed point of view, like what things are where, we can make some generalizations. So the first thing we're going to do is recognize that one possibility when we're dealing with two statements is that each of the statements individually are true. So I'm going to be our case in point. If I walk in and I say, I'm a woman and I teach math, you would say that is a true statement because I am a woman and because I do teach math. Make sense? Both statements are true, so this would be a true resulting statement. I'm going to pull some people from like OBU community, so you may or may not know them. I'll give you a little bit of background in case you don't. The next person we're going to pretend walks in here is Dr. Tucker. That's not a good one. Dr. Barbie, that's who I used this morning. Dr. Barbie. Do you guys know Dr. Barbie? Okay, so Dr. Barbie teaches communications. Her name is Kathleen, so obviously you would assume that means she's a woman, right? Kathleen Barbie. So it is 2022, but I will say we're at a Baptist university. So we're going to go with the Bible on this one. All right, so Dr. Barbie walks in and she says, I'm a woman, I teach math. And you're like, okay, cool on the woman part, but I haven't seen you on the list of math people. And she says, and you know that she teaches communications, so that's a false part of her statement, right? So she is a woman, she does teach communications, not math. So if she comes in and she makes the statement, I'm a woman and I teach math, that's actually a false statement. Because the word and in between. The word and in between means that I have to have both individual statements true for that to make sense. So this would be false. All right, third person. Do you guys know Dr. Drake? Got some people saying yes, some people saying no. Dr. Drake is in the math department, hence he teaches math, but his first name is Nate Drake. I think it sounds like Clark Kent. I'm pretty sure he's a superhero in disguise. So he walks in and he says, I'm a woman and I teach math. And you're like, no, right? So he is not a woman and he does teach math, those individual pieces, right? So combined together with the word and, that would actually be a false statement. All right, I know you know the last example I'm going to use. Dr. Thomas walks in, president of the university, and he says, I'm a woman and I teach math, and after you kind of pick yourself off the floor because it's kind of a funny thing for him to walk in and say, you're like, all right. Not a woman.
I teach math.
Not teaching math. So combined together, clearly a false statement. Okay, so this is what this truth table always looks like. So I've got my examples that I gave verbally, but let's actually look at the actual T's and F's and where they are, okay? So anytime you have two statements, P and Q is what's being used most of the time, the first column will say true, true, false, false. And the second column will say true, false, true, false. Doesn't matter. It doesn't matter anything else. So even if you can't finish a truth table, you can always start it because the order of the T's and F's are always the same. Okay? So inside of my math lab, I'm not sure if it will set up the columns or if it'll make you put the column headers. I'm not exactly sure how it's going to make you do it. Obviously, it can't just there's not a scratch paper. It doesn't work from scrap, right? But the T's and F's will be this way all the time with two statements. Okay? Notice when you're looking at this and statement, there's very little that's true in the and statement, right? Only one row is true, the row that says true, true already. So when we combine and statements, we usually get very little truth to the final column. Okay. You ready to do disjunctions? Okay. Over here. Or statements. Disjunctions. P or Q. So we talked about last time, we used the letter V in between to relate those. We talked about how there was a connection between or statements, disjunctions, and unions, and statements and intersections back from chapter 2. An or statement is true when either of the individual statements is true. We're going to use our same four people to discuss them walking in and making these claims with the word or instead. Okay, so after we've done one truth table, and I told you that the first two columns are already the same, you should be able to write me the first two columns. So you write your two columns. One header is P, one header is Q. It goes true, true, false, false, and then true, false. True, false. Okay, so all of that's always the same. It doesn't matter what comes next. P, Q, G's and F's in that arrangement. Everybody good? Now, what I'm trying to work with on this one is an or statement. So it's P or Q like that. Okay, so again, I walk in, me personally, and I say, I'm a woman or I teach math. And you'd probably think, well, why'd she say or? That's a little bit weird. And it is, right? But it's a true statement. I am a woman. I do teach math. So I am a woman or I teach math. I just happen to do both. Right? So I'm in this sort of both category right here that it describes above. Okay? Dr. Barbie walks in and she says, I'm a woman or I teach math. And you're like, okay, yes, you are. Right? Dr. Drake walks in and he says, I'm a woman or I teach math. And you say, okay, he teaches math, right? And then Dr. Thomas walks in and he says, I'm a woman or I teach math. And you're like, still not working for me, right? No.
You're a Hobbs boy.
Yes. What you got?
Well, since these columns are always going to be the same, does that mean for every single truth table that is an and statement, this column is going to be the same too, and with the or?
So it's interesting that you ask that because I had somebody in my other class ask that as well, and I don't know that anybody's ever asked me before in that way. So the answer is yes, But what's going to change is it's not always going to be PQ and then combine them with an and. We're going to have more than just PQ. It'll be PQ and R. Or there's going to be some negations involved where you've got to have some tildes. That's what's going to vary to make the truth tables vary later on. Yeah. Okay, is this all right? Notice the final column in an or statement is mostly true statements, right? The only one that's false is the one that says two falses. Yeah? All right. Any questions so far? Okay. The next few examples actually are a little bit different. They don't ask us to create a truth table. They ask us to find a truth value. Now we're going to use a modified truth table to do that. But notice what they give you at the beginning that we didn't have before. They tell you P is false and Q is true. So I don't need to represent all possibilities, right? That's what I did over here. This was all possibilities. All possibilities of trues and falses for P and Q. I don't need that over here. They tell me what my options are. And there aren't very many things they tell me, right? They're very specific. So what this actually ends up looking like is a truth table, but it only has one line. All right? Now, we look at the individual statement we're working with. This one says tilde P. And any of the statements that we are given have to show up as a column header. Well, there's only one statement. It's P. I don't have a Q column because there's not a Q in this argument. It's just P. And then what have they done to P? Well, they've negated it. That tilde means that I've negated something. It's the opposite of. We looked at that last time as well. Okay, so these are my column headers. And then we go to the information that we're given. What does it tell us about P? It's false. So if P is false, what is the negation of P? True. So this last piece that I wrote in here is the truth, the value that I'm looking for, and it's true. Okay? So these are much nicer problems because I don't have to do a full-blown truth table. I only need to do one line, the line that matches the information given. Okay, we're going to do the same thing for the next one. Now the next one does have a P and a Q, right? Both of them. So I do need a column header for P and for Q. But I got more going on, right, Isabella? You asked, are these always going to look this way? Well, this one's got more going on. I've got them combined with and in the parentheses. So I start working inside the parentheses just like I did with Venn diagrams, just like I do with algebra. I start inside. So I need a column header for P and Q. And that's the entire inside of my parenthesis. And then if I move to the outside, I have a column that would show me the tilde part. So I need the opposite of P and Q. Okay, so we're going to create column headers first. MyMathLab may help you with the creation of column headers, or it might simply give you the question much like this, and you're just going to have to write down true or false, and it's going to give you one attempt, right, Molly? And if you don't get it right, it's going to give you a new problem. You're going to have to start over again, okay? And guessing 5 times randomly is probably not your best bet at learning the material. You only get one guess on the test, right? Yeah. So what does it tell me that P is? True or false? What does it tell me that Q is? True. Now, we have to look at a true and a false combined together in an and statement. Is that result true or false?
False.
False. An and statement needs both statements true to be true. But anytime we do a negation of a column that we already have, right, the last column is supposed to be negating this column. What would I get if I negate the P and Q column? True. So my truth value would be true. Everybody good so far? Yeah? All right, similar on number 3, but what do you notice that's different? There's an R. I have 3 statements now. Now we'll look at a full-blown truth table for 3 statements later, but that's not what I'm asked to do here. I'm asked to do the same thing I did over here. They're giving me the truths and falses for each of the individual statements, and that's what I'm working with. So they tell me P is true, and they tell me Q and R are false. Okay? So I need to represent every single one of my individual statements as a column header that are involved in my problem. That involves P, Q, and R. So I need columns for all three. And then we're going to work like algebra from the inside out. So on the inside, I have Q or V. So this will say Q or, I'm sorry, I didn't say or V, or R is what I meant to say, Q or R. Okay, Q or R. And I'm going to do something a little bit helpful in terms of like writing it down for you. My math lab would probably put these column headers in and it wouldn't quite be the same. But in terms of writing it down, if we continue to write things, they become very long. Let me show you what I mean, and then I'll show you an alternative to doing so. The last column has to be P and Q or R. It has to include all of it. So what I'm going to do instead, as a space-saving tool, is that I'm going to call this thing that I had Q and R 1. You can label it 1. You could label it 4 if you think, because it's in the 4th place. I don't care. But it just saves me space on labeling my columns. And it'll become more necessary later, and you can see why I'm going to do that. But I'm just labeling it differently. Is everybody okay with my labeling?
Wait, so that one is a R?
No, the 1 is all of this. Q or R. I'm just saying that I'm replacing Q or R with the number 1.
So it's going to be P, that thing, and then it's going to be Q.
Or R.
Oh, okay.
Yeah. The reason it's helpful is because what we're really going to do is not go back to the column Q and the column R. We're really going to go back to the column that I've now labeled number 1. That's what we're going to be looking at anyway. So it gives me a reference point to where to go without it being quite so messy. Okay. P, true or false? I think it's true this time, isn't it? Yeah, true. Q, true or false? No worries. False. R, true or false? False. Okay, so those 3 were given to us. You should get those right every time in my math lab, right? Because it was given to you. The next one is an or statement, and it's an or statement that combines Q and R.
False.
So individually they're false, so their or statement would also be false. Okay. And then my last column says that I'm going to look at column P, and I'm going to look at column 1. So they're the ones I've highlighted in blue now. Feel free to use some colors on your paper as you're sketching things out if it helps you. If it doesn't help you, then don't. But it helps me, at least, to see them individually. And then it'll help more when we get to the full truth tables, too. So I need an and statement, right, of the 2 blue columns. The first blue column is true. The second blue column is false. And when I combine a false and a true statement together with an and, what do I get?
False.
I get false. So the truth value here is false. Any questions so far? Okay, when we were creating this truth table over here,
Wait, I
and
have
the
a
first one.
question.
Oh, yes, Imani, what you got?
You had Q and R, they're both false, so why wouldn't they be true?
And statements need to have 2 statements true to be true. Right? Otherwise, it's the Dr. Thomas example. Right? He walks in and says, I'm a woman and I teach math. And you're like, nope, because both those individual statements are false. If we want to look at this one where they're blue, one of them's true, one of them's false, that would be the example of either Dr. Drake or Dr. Barbie walking in. The individual statements, one's true, one's false, but I can't put an and between them and make a true statement. Or I could, but not and.
Okay.
Okay?
But since that one's an or one, because they're both false, it's still gonna be false.
Correct. That's Dr. Thomas, right? So the one that I highlighted with the yellows were both individually false. which means that the combined or statement is also false. Yeah. All right. Over here, our truth tables where I did out the whole truth table. I kind of talked through, these are the different 4 options, right? Both can be true, one can be true and the other one can be false, or vice versa, or the last option is that they're both false. And I ended up with 4 rows, yes? Okay, so generally speaking, the way that I know how many rows that I have depends on the number of individual statements for a full truth table. So a truth table will actually have 2 to the n rows, and the n is the number of statements. So this n right here represents the number of statements. Now, the 2 examples that I've done full truth tables on had 2 statements. So 2 squared is equal to 4, thank you. And I had the 4 rows, right? So 2 statements, I have 4 rows. What if I had 3 statements? How many rows would I have?
What's your?
Say it louder. 8. Yeah, I'd have 2 cubed, which is 8 rows. What if I had 4 statements? You know what 2 to the 4th is? 16, and you won't have that many. We're going to do 2 statements or 3 statements. Those are our choices, okay? So take a look at this example, number 4. How many statements do you actually have here? It's 2. Kind of looks like 3, but it's 2. Why is it 2?
P is used twice.
P is used twice. So you're looking for different letters. I mean, that's what represents different statements. This is just two statements. They're just being combined more than one time, okay? So when I'm creating my truth table here, I need to make sure that I'm not creating column headers that don't really exist. I only want column headers for the individual statements, which would include P and Q. And I will always have column headers for each of the individual statements. So this is P and Q this time. And then even if I can't continue on, like with column headers at this point, I should be able to fill in the columns for P and Q. What will go in the P column? True, true. False, false. What will go in the Q column? True, false. True, false. Okay, everybody good so far? You should be able to do that every single time because it's exactly the same thing over and over again. After that, we were going to look at this compound statement we were given, and we're going to start with the inside. Now notice on the inside, I don't just have P and Q. I have P and the negation of Q. So I need a column representing the negation of Q. Okay? Going to have a column for it. And then I can work on the entire part of the inside of the parentheses. I will have P and tilde Q. Now the part that's in parentheses is going to be combined with something later. You don't have to do it this way, but this is what I did just a moment ago. I'm just going to call it 1 so that I don't have to keep writing it over again. I'm just relabeling it. This is the same thing as 1. And now I'm going to take that column, 1, and join it with an OR statement with P. Okay? So this last column that I created takes the previous column, which was P and tilde Q, and it combines it according to the statement I was given with a OR statement with P. Okay, everybody good so far? Now we got to do a whole truth table this time instead of just one line, like we were on the last couple. So you've got a Q column. It's true, false, true, false. So what's tilde Q going to be? You got it. False, true, false, true. Okay, tilde columns are pretty straightforward. They just reverse everything. Then I need to combine P and tilde Q. So I'm highlighting them all in blue. So only columns I consider, and I'm going to work across the row. So on row 1, Isabella,
Okay, so if it would have been the negation of P, would it have been false, false, true, true? Or is
Yes.
it just, okay.
yes, it would have. If I had negation of P, I would have false, false, true, true. And it's also worth noting, though I didn't say it already, we don't want to create a tilde P column unless we need it. So it's not like I'm always going to create all the tildes. I'm only going to create the tildes I need. So do be aware of that. We're not trying to make the biggest truth table possible. We just need the pieces that are present in our problem. Okay, row 1. Okay, in row 1, I have true in the first column, have a false in my third column, and I'm supposed to be making an and statement. So true and false is a false statement. Row 2, true in the first column, true in the third column, true and true is true. The third one, false in the first column, false in the third column, false and false is false. The last one, false in the first column, true in the third column, false and true is false. Okay, I'm going to change colors. Use yellow. Now I'm supposed to use the column number 1, right, and P, which are now highlighted in yellow. So I'm looking at my 2 yellow columns, and I'm joining them with an or statement. So when are or statements true? When one of them is true. Okay? So along the first row, I have true, and I have false in yellow. True and false would be true. In the second row, I have true and true. That's true. In the second row, or third row, excuse me, I have false and false. False. And in my last row, I have false and false. False. Now there's no sort of answer at the end because I wasn't asked to find a truth value. I was asked to create the truth table. Okay? I don't know what the truth value is because I don't know which line I'm really on. I'm just exploring all possibilities in a big giant diagram. Okay, everybody good so far? Okay, our truth table is going to get bigger. Why is our truth table bigger on 5? There are 3 statements. So there are 3 statements, which means how many rows am I going to have? 8 rows. Good job, Ren. 2 to the third, 8 rows. Okay. So let's start with the 3 headers that we know, and we'll write them in alphabetical order. We always write them as PQR. So we have column P, column Q, and column R. Okay, so just like before, I have 8 rows, but just like before, I'm trying to explore all the possible ways true and false can happen combined together for the statements. So I'm going to argue my way through writing them all down, and then I'm going to show you the patterns that are present so that you'll know how they always work. Okay? So the first option is that they're all true. The second option is that the first 2 are true and the last one's false. The third option is the first one's true and the middle one's false and the last one's true. The fourth option is that the first one's true and the last 2 are false. Do you have a question, Hallie?
Where did that come from? Because I thought P and Q was true, true, false, false, and true, false, true, false.
It is when we have 2 statements, but we've got 3 now. So we have to have all possibilities when we combine all 3 statements together. So it's kind of like having the 3 independent statements. Like let's say I had the same ones I had before. I'm a woman, I teach math, and the third one is I like Wendy's. Okay, well, me liking Wendy's actually expands everything to having twice as many options now because I either do or I don't. Right? So I walk in, Dr. Drake walks in, Dr. Thomas walks in, Dr. Barbie walks in, but their liking Wendy's actually creates twice as many options at the end because they either do or they don't. So these are all the true ways that P can happen, and now we're going to do all the ways that are false. So it could be that the first one's false and the second 2 are true. It could be that P is false and Q is true and R is false. It could be that P is false and Q is false, but R is true. Or they could all be false. Now, to come back to what you noticed before, Hallie, notice what happens here that's similar. Column P splits. 4 trues, 4 falses. Column Q is in pairs. True, true, false, false, true, true, false, false. And column R is the oscillating. True, false, true, false, true, false. All the way down. Okay? So when we have 3 statements, these will always be the 3 columns. When we have 2 statements, they're the ones we did before. Okay, so it will always start out like this with 3 statements. The next thing I would encourage you to do is to look at whether you have any tildes involved. And then let's make column headers for them. So are there any tildes involved? Yes. What do we have? Tilde Q. So we'll make a column for tilde Q. And it's solely based on Q, right? So Q is true, true, false, false, true, true, false, false. So what will tilde Q be?
False, false, true, true, false, false, true, true.
Right. False, false, true, true. False, false, true, true. Okay? Can I get an amen on tilde columns? They're nice. Very predictable. Okay. Everything else after the tildes is a little bit more work. So we work from the inside out. The inside of parentheses is the P and tilde Q. So I'm going to highlight them in yellow. Here's P. Here's tilde Q. That's what I'm going to call my yellow column. Okay? We're just going to go down them. We can do all the labels first, or we can actually go down the truth table first. I kind of go back and forth. So we'll go down this column first. And yellow, and statements. When are and statements true? When both are true. So we could actually probably say from the very first get-go then, if you look at the last 4 rows, they're false. Because P's false in the last 4 places, right? So guaranteed my last 4 locations have to be false because P's false. Okay? So you don't have to go from the top down. It doesn't matter. If I do look at the top, I have 4 trues, right? So now it's hinging upon tilde Q. And if tilde Q is true, it'll be true. And if tilde Q is false, it'll be false. So my first 2 rows have tilde Q being false. So this is false. You can go by, one at a time, or you can do it sort of like this, bulking things together like I am at the moment. It doesn't matter. You'll get the same answers. But in the middle 2 rows that I haven't done now, which is rows 3 and rows 4, it's true in the P column and it's true in the tilde Q column, right? So these 2 statements are true. Any questions on that column? Okay. So again, for simplification purposes, I'm going to call this P and tilde Q 1. And I'm going to join it together with R and an OR statement. So this is R or 1. If you want to write it all out instead of labeling 1s and 2s, it doesn't matter. That's fine. Okay, so I'm going to highlight them a different color. We'll go with the same blue I used before. Column R. And now I'm looking at column 1, which is P and tilde Q. The blue columns are what I'm working with. And I want an OR statement. When is an OR statement true? When at least one of them is true, right? At least one. So looking at the first row, we'll go row by row on this one. So I have blue lines only. True, false. That statement would be true. Row 2, I have false, false. False. Row 3, I have true, true.
True.
Row 4, I have false, true.
True.
Row 5, I have true, false.
True.
Row 6, I have false, false.
False.
Row 7 is true, false.
True.
And the last one's false, false, giving me
False.
false. This would be the complete truth table, and you all say, thank you so much, Dr. Hans, for not giving us one with 4, right? 3 statements is plenty big of a truth table for us to work with. However, there are some places in my math lab where it might ask you how many it would create, right? So if it asked you and it gave you a compound statement, you could answer the statement without doing a whole truth table for plenty of options. Did it give me 5 statements? Well, it's 2 to the 5th. That's 32. Okay, so whatever it gives you for that, that's a simple, just plugging it into a formula. It's not asking you to draw the whole table out. So that is a possibility. All right, the last thing for today we're going to look at are called De Morgan's laws. De Morgan's laws talk about how we negate a compound statement. So you see the tilde in the front, and then you see this compound statement that's either the union or the intersection kind of ones, right? Ands or ors, disjunctions, conjunctions, all that kind of stuff in the middle. And it shows how you sort of like move the tilde through the problem. This kind of a distributive idea. And what I want you to notice is that there are 3 pieces here that it has to apply to. P, the conjunction or disjunction sign, and Q. And they all change. So the P becomes tilde P. The or becomes and the Q becomes tilde Q. And this applies even when they don't start out so nice and pretty. For example, let's say that you had the negation on the outside and it said P or tilde Q like this. Well, the negation of P is tilde P. The negation of or is and. What's the negation of tilde Q? Q, yeah. Right? Kind of like that whole negative times a negative is equal to a positive thing, right, with numerical values. Same idea. Okay, so we can use De Morgan's law as it applies to any symbols, whether they have negations on them or not to start with. The thing to remember, and the most commonly missed thing, is to remember to change the ands and the ors. So how do I expect this to be showing up in my math lab? I expect it to show up as multiple choice. And I expect one of your choices to be the same thing that it should be, but with the wrong symbol in between, either symbolically or like with words. It says and it should be or. That's going to be one of the options that you're going to have to select from, so be careful. So when you're writing these down or thinking through them, I want to think through them as being 3 separate pieces of information. There are 2 statements, and they're joined in the middle with either and or. And we want to make sure we change every single piece. So my first statement says, it is summer. What's the negation of it is summer? Yeah, it is not summer. Then we get to the connective, the word and needs to change. To what? Or. And then we have our last piece. There is no snow. What's the negation of there is no snow? There is snow. Okay, so that's sort of like a prescriptive, like do this, do this, do this. But let's actually think about it from the standpoint of the language that's involved. If somebody walked in today, if I walked in today and said, it is summer and there is no snow. All right, and let's presume for the moment that that's a false statement. Well, what could be false about it? Well, it could be that the part that says it is summer, right, because this is actually a false statement for today anyway, right? If the false part could be the first part, it is summer, so it could be that it's not summer, right? Or it could be that the statement that says there is no snow, that there really, really is snow. And I don't need both of those things to be changed in order to make the entire original statement false, right? I just need one of them because it was an and statement. And all it takes for an and statement to be false is one of the individual pieces to be backwards, to be wrong. That's why it's an or in between. I just need one of them to be false now. So I create the statement that's the negation, because the negation of a false statement creates a true statement, and vice versa. Does that make sense? All right, we're going to stop there for today.